Thank you so much for joining this lesson. We'll be discussing the Alliance High School mock. This is the August exam 2025 in preparation for the KCSE 2025. So you're most welcome. We're going to discuss the session 1 and later the session 2 of the same paper. Number 1, find the selling price of 5 kilograms of a mixture of maize flour and millet flour if 4 kilograms of maize flour costing 75 shillings per kilogram is mixed with 6 kilograms of millet flour costing 50 per kilogram and a profit of 20 is realized. This is a very serious setting. I want us to just analyze it stepwise. Look at this. We're supposed to say first, we are mixing 4 kilograms of maize, each costing 75. So let's guess the cost of the mixture per kilogram, of course. Then the 6 kilograms of millet, 6 kilograms of millet, and each is costing 50. So this will be the total cost of the mixture, but we want to get per kilogram. Then we have to divide by the number of kilograms which have been mixed so that we know the amount per kilogram in this mixture. So this is giving me 600. When I divide by the 10, now I will get 60. So the cost price of 1 kilogram of the mixture is 60 Kenya shillings. But now, the shopkeeper who is doing this is supposed to realize 20% profit. So 120% means now inclusive of the profit. So 120% of 60. So that we know the selling price of 1 kilogram of the mixture with 20% profit. This is exactly 72 Kenya shillings. So a kilogram should be sold at 72 Kenya shillings. But now the question is the selling price of 5 kilograms of the mixture. So we want now to sell 5 kilograms of this mixture. How much should it cost? So we multiply by 5. 72 by 5. This gives us 360 Kenya shillings. 360. So that's how the first part is supposed to be done. A very simple question, yet involved. Number 2. The radius of a cylinder is given as 3.50 centimeters, while its height is exactly 12 centimeters. Mark the word exactly, 12 centimeters. Find the percentage error in the volume of the cylinder, giving your answer to 3 significant figures. Take pi as 22/7. Allow me start utilizing the space up here. I've just realized that the spacing is not the spacing is a bit limited in this paper. So in number 2, when we start solving, now I will talk about the range within which the radius lies. So we first establish the absolute error in the recording of this radius. And before we establish the absolute error, we are supposed to establish the accuracy, because absolute error in the recording of a dimension is usually given by accuracy divided by 2. So the accuracy is 2 decimal places. So 0.01. This should be divided by 2 to give us absolute error. The accuracy divided by 2 gives us absolute error. So this is 0.005 centimeters. Sorry, 0.005. These are centimeters, yeah? Then now, this absolute error is what shall help us to know the range for the radius. So we take 3 0.50, we add or subtract 0.005. So the radius will range between, when we subtract, we are getting 3.495 centimeters, all the way to, when we add, it shall be 3.505 centimeters. That is now the range. The lower limit of the recording and the upper limit. Remember, the height is exact. So there are no limits within which the height was recorded. It's just an exact value. So at this point now, we can say we find maximum volume, whereby we say that in a cylinder, to get volume, we need cross-section area times height. Therefore, pi r squared, so 3.505, and we square this times the height, which is exact. This will give us the maximum height. So 22/7 multiplied by 3.505 squared, I multiply by 12. This gives us 463.321 cubic centimeters. Then volume minimum. Here we need the pi, which is a constant, times the lower limit of the radius, 495 squared, then times the fixed height of 12. 22/7 multiplied by 3.495, we square this, multiplied by 12. This is going to be 460.681 cubic centimeters. What about the actual volume? The actual volume is volume computed using the measurements just as they were captured, just as they have been recorded. 3.50 squared times 12. So 22/7 multiplied by 3.5 squared multiplied by 12. This gives us exactly 462. At this point now, whereby we are having maximum volume, minimum volume, and actual volume, we can now find something that we call absolute error in the computations of volume. Absolute error in the computation of volume. Remember, there was absolute error in the recording of radius, but now we are talking about a different absolute error in the computation of these values, whereby we say absolute error in computation is usually given by maximum minus minimum over 2. So 463.321 minus 460.681. Then this now should be divided by 2. So what we get is the absolute error. Let me compute that. I'm taking 463.321 minus 460.681. This gives us when we divide by 2, 1.32. So we can proceed to relative error, which is given by absolute error divided by actual volume. Then for us to get percentage error, for us now to proceed and get the percentage error, then we will need the relative error, which is here, expressed as a percentage. Yeah, we just express it as a percentage. And this shall be exactly 0.286%. This is according to the number of significant figures that the answer is needed at 3 significant figures that way. Now we proceed to number 3 in this paper. As we continue learning, kindly, it's good for you to remember our program here for the December holiday. We are organizing one term ahead program, whereby from the 20th of November to 12th December on Google Meet, we shall be having a very serious program. We'll be covering the term 1 work of 2026. This is involving the grade 7s, 8s, and 9s of next year, and also the Form 3s and Form 4s. So for more details, please reach out through the number attached here. You can call, text, or reach out through WhatsApp 0704 15 33 66. So please contact us. Reach out for more details so that we may learn together via Google Meet. It's a very interactive forum whereby learners can ask questions, learners can answer to questions, learners can seek clarification, among very many other advantages of the features in Google Meet. So kindly reach out, register, see you online for some learning. Shifting Grades, the home of academics, is inviting you to the serious program. Look at number 3. Solve the equation logarithm 2 base 2 of 2x squared minus 8 minus the logarithm 2 base 2 of x plus 2 equals to 3. Look at the base which has been applied in this question. Then through that, you can allow me apply the law that says when we have the log of a certain base to the same base, the value is usually 1. Now that this is true, then we can introduce the log of 2 to base 2 where there is 3. And that way, the value of 3 shall not be affected. So we can rewrite and say the log to base 2 of 2x squared minus 8 minus the log to base 2 x plus 2 equals to 3 multiplied by the log of 2 to base 2. You see that we have not changed the value of 3 because 3 multiplied by log 2 to base 2, that value is just the same. At this point now, we can apply a few other laws. For example, we can say that when we take the log to base 2, then we should be able to divide 2x squared minus 8 by x plus 2. And this is equal to log to base 2 of 2 power 3, which is 8. 2 power 3 because we all know that n, the log of a, is the same as log a power n. Therefore, 3 becomes power of 2. So 2 power 3 gives us 8. At that point now we can drop the logarithms, then we quit the right hand side to the left hand side. In this way, x squared, 2x squared minus 8 out of x plus 2 equals to 8. Because the bases are the same, logs can be dropped that way. 2x squared minus 8 equals to 8x plus 16. 2x squared minus 8x, then we can have minus 24 equals to 0. You see that? Then we can divide through by 2 to make the equation as simple as possible. I know it can be solved at a different stage. At the same stage, it can still be solved to give us the same roots. But now when we simplify it, look at this. When we simplify, it shall become x squared minus 4x minus 12 equals to 0. Allow me solve it using the factorization method, whereby I need a product of a times c, negative 12, and a sum of the value at B, which is a -4. The two terms are -6 and +2. Product, -12. Sum, -4. So those are the two factors. And now we can apply them and say x squared minus 6x plus 2x minus 12 equals to 0. Then we factor out 12. X minus 6, we factor out 2. X minus 6 equals to 0. So from the first two terms, we can factor out x. And from the next pair of terms, we factor out 2. From the brackets inside, we have the same in both cases. But now outside the brackets is x plus 2. This is now equal to 0. Equal to 0. Then let's talk about each of them can be 0. So x minus 6 equals to 0, meaning that x equals to 6. Or from the other bracket, x plus 2 equals to 0, meaning that x equals to -2. Yeah? Meaning that x equals to -2. Like that. We check number 5, which says we make, okay, before number 5, sorry, because of the spaces that I'm trying to manage, I've skipped number 4, whereby we are told to solve the equation by completing the square method. So let's solve this quadratic equation using the completing square method, because we've already written this and you can still take screenshots of the same. Allow me now, Rab, so that I may use the space to work out a certain equation here. A very simple question whereby the examiner has already chosen the method that you're supposed to use in the solution of this particular simultaneous equation. So first, we are supposed to make the coefficient of x squared 1. We divide through by whatever constant is here. So this is supposed to be x squared plus 5x plus 6 equals to 0. You see now, x squared plus 5x equals to -6. So there is a constant that we are supposed to add on both sides. And this constant should be added in such a way that the intention is to make the left-hand side a perfect square. So how do you ensure that? The constant is related with the other terms in such a way that b over 2 squared should give us that particular constant. So b is 5. 5 over 2 squared, that gives us 25 over 4. Yeah. Then we also add 25 over 4 on this side. After that, we can talk about factorizing the left-hand side, whereby we factorize a perfect square by taking the square root of the first term, which is x, the sign that follows, which is a plus, square root of the constant, which is 5 over 2. This is equal to, okay, squared. That's how we factorize squared. Then on the other side, -6 plus 25 over 4. This is giving us a quarter. So we can now take square root. X plus 5 over 2 equals to plus or minus half. Yeah, that way. So the value of x then, the value of x shall be, we have half minus 5 over 2, giving us -2, or negative half minus 5 over 2. This gives us -3. So that is it now. That is it. That is it. A very simple question. So it's my hope that you can catch up with such working. Very simple, very simple. The next question. The next question, which is number 5. Hello, sir. Hello? Hello? Poa sana. Unaweza nipea some minutes. I'm doing a certain presentation and I'll call back. Yes. Yes. Mm-hmm. Mm-hmm. Yeah, please give me around 30 minutes. I'll get back to you, please. I mean, I'm doing a presentation actually. Okay. Make B the subject of the formula. We are making B the subject of the formula now in number 5. So we can see that there is a root sign somewhere. There is a root sign. Therefore, let's begin by squaring everything just to do away with that root sign. X squared equals to A squared out of A minus B, A plus B, that way. Then now we are supposed to know that the denominator on the right-hand side can be expanded. So this is X squared equals to A squared out of A squared minus B squared, that way. So we expand. It's a difference of two squares, so we don't need to waste a lot of time. You expand automatically. Let's cross multiply such that we can have a squared because it multiplies only one. Then x squared multiplies a squared minus x squared multiplying b squared, that way. X squared this way. X squared multiplies everything here, and 1 multiplies everything there. Then now we can have the terms with b on the left-hand side, making them positive, equals to minus a squared, that way. At this point, we can remain with b squared equals to x squared, a squared minus a squared out of x squared. Yeah, out of x squared. Then at this point now, we can talk about square root. So that remain with b equals to plus or minus the square root of remember the numerator can still be factorized to x a minus a and x a plus a, since it's a difference of two squares. Everything out of x squared. Yeah, everything out of x squared. So that is it. That is it. Only simplified. A very good question. Number 6. As we go to number 6, allow me also bring to your attention a serious program here that we are doing with day school students. If you are a candidate this year, kindly purpose to join our mentorship programs every Sunday from 7:30 p.m. to 9 p.m. We have a very serious program via Google Meet still, whereby now here we interact, you ask questions, you get to know what is right as we target the KCSE 2025. So all the best. Continue joining our programs. Let's now continue with the discussion of the paper, but you're most welcome to our Sunday programs. The number is already attached. Please chat me in WhatsApp for more clarifications. Number 6, we are simplifying the expression. Today is a day for differences of two squares. So the denominator, this is a third. So treat it like any other fraction. Like have 7 minus 2 the root of 3 into 7 plus 2 the root of 3, like that as our LCM. LCM divided by the first denominator, we will get, then multiply by the numerator, we'll be having 7 plus 2 root 3, then minus 2 multiplied by the same LCM divided by the second denominator, we'll get the part with a minus. So 7 minus 2 root 3. We can expand 35 plus 10, the root of 2, minus 14 plus 4, the root of 3. Then this should be divided by, this is supposed to be divided by, from the denominator, now we can expand a difference of 2 squares, whereby you just need to square 7, then 2 root 3 also squared, and you subtract. So we are getting 49 minus 2 root 3 squared becomes 4 root 9. Root 9 is 3. So 4 root 9 is 12. 4 times 3, which is 12. Yeah. We can continue grouping terms and simplifying where possible. 35 minus 14 gives us 21. Then plus 10, the root of 2, plus 4, the root of 3, out of 37. Yeah, out of 37. So this is now the most simplified because there is nothing that we can add on the numerator. There is nothing that we can simplify from the denominator. So that is it. That is simply how we supposed to work it out. A very simple question. At number 7 now. At number 7, triangle ABC is such that AB equals to 10 centimeters, BC equals to 12 centimeters, and AC equals to 20 centimeters. Calculate, correct to 2 decimal places, the angle ABC. So let me first sketch this information about the triangle. Just a sketch. You know what a sketch is? Just a simple diagram whereby dimensions are not indicated to scale. This is A, B, C. AB 10 centimeters, BC 12 centimeters, AC 20 centimeters. Then we are told to find the angle at B, ABC, this one. So that angle B, in other words, B in caps. So we say the opposite length to that angle, 20 squared, equals to 12 squared plus 10 squared minus 2 into 12 times 10, the cosine of the angle at B. So we can now take 20 squared, we subtract 12 squared, we subtract again 10 squared. This gives us 156 equals to negative 2, that is 24, negative 240. The cosine of B. So how will you remain with the cosine of B? We divide through by negative 240. This will give us negative 0.65. And how shall you remain with B? By finding the cos inverse. Shift cosine of this value. I'm getting 130.54. 130.54 degrees. So that is the angle that we wanted. A circle passes through the vertices of triangle ABC. Calculate the radius of the circle. So a circle which inscribes the particular triangle, this particular circle should have a radius whereby when the radius is multiplied by 2, we should get the cosine rule. We should get the sine rule, sorry. So the sine rule says that the angle at A, which we give in small letters now, the sine rule Remember what we have applied here is the cosine rule to get the angle. So now the cosine rule says that the length A out of the sine of the angle at A should be the same as B out of the sine of the angle at B equal to the length C out of the sine of the angle at C. So with this understanding now, we say this is equal to twice the radius of the circle. Yeah, twice the radius of the circle. Therefore, we can consider the angle that we have already identified, and that is the angle at B. Remember, we say 20 out of the sine of 130.54 should be the same as twice the radius. So how shall you remain with radius? You divide by 2 both sides. When you divide by 2, it shall be 20 divided by 2, the sine of 130.54. This is exactly 13.59 centimeters. Yeah, 13.59 centimeters. Actually. Proceeding to number 8. Again, a very good question in number 8. Let's look at it. Karanu bought a computer whose marked price was 25,000 on higher purchase terms. She paid a deposit of 25% of the cash price and cleared the balance by 12 equal monthly installments of 2,000 each. Calculate the rate of compound interest charged per month. It's good for you to note one thing here. Very good for you to understand this. That when higher purchase has been involved and a deposit has been made, then interest is compounded on the balance that remains. So what was the deposit first? We're using just this space. The deposit is supposed to be 25% of the cash price. Yeah. This is a 25 over 100 times 25,000. So we are getting 6250. This is the deposit that was made. That means there is the balance now. The balance that earned interest. 25,000 minus the deposit made, 18,750. This is now the balance, which is going to be earning interest. This balance can also be called our principal because it is the money that shall earn interest. So it's our principal amount. Then we can also say that there is the total installments, which becomes our amount. At the end of it, instead of settling a balance, which was 18,750, now we will have this person clearing an amount which is equal to 2,000 times 12 months. 12 times 2,000, giving us 24,000. So that is the amount we will pay. This amount can also be called our total installments. So total installments now. Total installments is our amount in this case. So Karanu is going to pay 24,000 after 12 months instead of the balance that was 18,750, meaning that this particular balance has earned some interest until it became the amount which has been stated here. So let's follow through in the spaces whereby we say, you know, amount is usually given by principal into 1 plus rate over 100 raised to n. So 24,000 equals to principal 18,750. 1 plus a known rate raised to the number of interest periods, 12 months. So we can divide through first by 18,750, giving us 1.28. So 1.28 equals to 1 plus r over 100 raised to power 12. Now we can take the 12 through to both sides. 12 shift power of 1.28, giving us 1.28. 0.02078. Yeah, equals to 1 plus r over 100. I've taken the 12th root on both sides. So we can subtract 1 from both sides such that 0.02078 equals to r over 100. How do you remain with r? By multiplying by 100 through. So 2.078% is the rate of compound interest per month. The rate of compound interest per month. So now we shall be focusing on number 9. Hope I'm not skipping any question because of the spaces. Ladies and gentlemen, remember to subscribe. Remember to share so that you may invite a friend to this particular platform. Number 10. Given that point A, which is 4, -2, 6, and point B, -2, 1, -3, and that point A, that point N divides AB in the ratio -2:5. Find the vector ON in terms of I, J, and K, in terms of the unit vectors. So this is how we shall flow in this particular question. This is how we shall flow. Look at it this way. Upon seeing the ratio, which is a -2:5, it should dawn to you that N is an external point that divides vector A, B. So we are having N here. N divides vector AB externally. You know, this says what? When we talk about -2:5, yeah, -2:5. Actually, I don't even think I'm putting it in the right way. Let me just draw it slowly without rushing for anything. We are having a point A and another point is N. Then point B shall be somewhere here. Let me interpret it slowly for you. If point A and B are on a line, then point N is dividing them in the ratio -2:5. Then it means this, that from point A to where N is, we go to one direction for 2 units. One direction for 2 units. Then from N to where B is, we shall move in the opposite direction 5 units. So from N to B, 5 units. So 5 units means that we shall pass through the 2 units. Look at this. This is -2, then +5 in the opposite direction. +5 in the opposite direction, this way. Meaning that we shall remain with 3 proportions there. +2, -2, then -2, then +5. So that's how the ratios are supposed to be distributed. From B to A, 3 proportions, and from A to N, 2 proportions. Remember, these alternatively can be treated as, we can have A and B at that point. Then we say from A, which is our initial point, to where the external divider is, we go backwards for 2 units. Then from the dividing point to where B is, 5 units in the positive direction. So 5 units means we shall pass through the 2 and we add 3 more. See that? Yeah, we add 3 more. So we can apply now, because we have known how to distribute the ratio now, we can apply the ratio theorem. Now, the ratio theorem states this. Assume the diagram is this one, because I want to use the most relative diagram, and it's what we have. We say this using the ratio theorem. The coordinates of A are given by, let's say these ratios was X and Y, unknown, because I want to state the ratio theorem in a very universal way, or rather, yeah, in a universal way, the general statement of the theorem. When we take the ratio x, then we divide by the total proportions x plus y. Then because we picked x, this we multiply by b, and we add y divided by the sum. Then because you've picked y, we pick the opposite vector n. Then we get the coordinates of the point and the mid. This way, it means when we take 2 out of the total proportions, which is 5, we should multiply this by the coordinates of b. And is the coordinates of b known? Yes. The coordinates of b is known as -2, 1, -3. Then plus, we pick 3 units divided by 5, the total. If we pick 3, then we talk about vector n, which is unknown. This is equal to the coordinates of A at the mid, 4, -2, 6. Yeah, 4, -2, 6. That way. So now we can work it out. We can remain with 3 out of 5, x equals to, I'm starting with the x component. Now take 4, and because from the left we are having -4 over 5, then it shall be 4 plus 4 over 5. This is 4 and 4 over 5. So to get x now, we can multiply by 5 over 3. This is going to be exactly 8. Then we go to the z, okay, the y component first. The y component, and we can say negative, okay, 2 over 5 by 1 remains 2 over 5. Then we add 3 over 5y. This now becomes -2. So 3 out of 5y equals to -2 minus 2 over 5, -2, and 2 over 5. How would you remain with y? Let me check that. We multiply this by 5 over 3. This will give us exactly -4. Yeah, getting -4 that way. Then we check another part, which is the z. The z component, whereby we shall say now 2 out of 5 multiplied by -3. That shall become -6 over 5. Z plus 3 out of 5. This is z. The first one is no z. This one now from this point here. 3 over 5, that's multiplying z, equals to 6. So that's to remain with 3 out of 5 z. Then we need to take 6 plus 6 over 5. This gives us 7 and 1 over 5, meaning that the value of z can be gotten when we multiply both sides by 5 over 3. And this gives me exactly 12. Now that we have the coordinates of n, n now shall be 8, -4, 12. Then the position, that's the coordinate. The position vector in terms of unit vectors shall be ON equals to 8I minus 4J plus 12, the value of K. So that's how we are supposed to give the final answer. Thank you for being around. Please remember to subscribe. Remember to share with friends so that you may benefit just as your friends. Just as your friends. We are now at number 11, right? Is there a question that we are skipping? Yeah, number 9, which is trigonometric. So let's check the trigonometric question. Let's check the trigonometric question in number 9. I think that one I've not solved. You are going to bear with me because of the spaces. Please bear with me. because of the spaces. But I will do what is humanly possible to ensure that everything is properly worked out. Yeah. This is trigonometry 3, actually Form 4 work, whereby we're supposed to apply some trigonometric identities. Eight, the cosine of x equals to the sine squared of x plus 6. Then the range of the values of x is 0 degrees all the way to 360 degrees. Whenever you see trigonometric ratios and one of them has been squared, you are supposed to think of one trigonometric identity. Which trigonometric identity is this? In Form 4, we said that when we have the sine squared of an angle plus the cosine squared of the same angle, this is equal to 1, a trigonometric identity. So we can make sine the subject and say the sine squared of theta equals to 1 minus the cosine squared of theta. Then if that is so, we shall apply it at this point and say, we can begin the expression and say, the cosine, okay, 8 cosine x is the same as, instead of sine squared of x, now we can have 1 minus the cos squared of x. This time round, the unknown is x plus 6. That's now clear, right? So we can now arrange so that this particular equation takes a quadratic shape. In this way, we start with the cosine squared of x. Then, yeah, we bring it to the left, it becomes positive. Then we are already having 8, the cosine of x. Then we can have the 7 becoming negative to remain with 0 at this point. Then to make it simpler, just to make it simpler, we can let the cosine of x be a certain unknown like y. If we let it to be y, then we'll be having y squared plus 8y minus 7 equals to 0. With this knowledge now, with this understanding, ladies and gentlemen, we can now solve it quadratically. Product of a times c, negative 7, sum positive 8. Sum positive 8. I don't know whether we have these factors whereby we multiply them to get negative 7, then adding them gives us positive 8. I don't know whether there are such factors because 7 itself is a prime factor. 7 itself is a prime factor, so it can be factorized. It's just 7 and 1. Just 7 and 1. So now that we don't have such factors, we can apply a different formula. Let's check a different formula, but I will also be checking the arrangement of the terms in that particular equation. So we can talk about, we used the completing square method at some point. So now we can change our gears to, we also used factorization actually. So we can change to the quadratic formula whereby the value of y will be given by negative 8 plus or minus the square root of 8 squared minus 4 multiplied by AC, 1 times negative 7. Then we divide everything here we shall divide everything by 2. Yeah, 2 multiplied by A is just 2. This is going to be y equals to -8 plus or minus. We shall have 64, then minus 38, which becomes positive 28, that is positive 28. This becomes 92 out of 2. -8 plus or minus the square root of 92 shall be 9.59 out of 2. So the values of y shall be, when I take -8, and I add 9.59, then I divide by 2, I'm getting 0.7958. You see, these are values where we could not get factors now. So that's now the essence of the quadratic formula. Or the value of y equals to -8 minus 9.59, then we divide by 2. This is -8.795, whereby we can't deal with absolute values which are greater than 1 when talking about cosines. So we just work with the first option of y. We work with the first option of y. Yeah, the first option of y. Allow me to clear the board so that we may continue with convenience. So that our continuation becomes very convenient. Yeah, very convenient. So now we say this: the cosine of x, which had been let to be y, is now 0.7958. So let's identify a certain angle. Just before we get the exact values of x, we identify a certain angle which is equal to the cos inverse of 0.7958. This acute angle shall be used now to help us. So shift cosine of 0.7958. This is equal to 37.27. 37.27 degrees, actually. Yeah, at 7.27 degrees. Then with this, we can now place this angle for us to get the values of x. We place it in the quadrants where cosines are positive. Quadrants where cosines are positive. Just a brief reminder of the unit circle. A brief reminder of the unit circle. Yeah. So now we are supposed to know that with this unit circle, all the trigonometric ratios are positive in the first quadrant. Sine alone is positive in the second. Tangent alone is positive in the third. And cosine alone is positive in the fourth quadrant. Therefore, the values of x shall be, the first option is the first acute angle, that's 7.27. And the second value of x shall be the same acute angle, but in the quadrant where cosines are negative, which is in the fourth quadrant. Here we talk about the value of theta the way it is. Here we get the angle by taking 180 minus theta. Here 180 plus theta. And in the fourth quadrant, it should be 360 minus theta that way. Therefore, 360 minus this value, you'll be getting 322.73. 322.73 that way. So those are the only two angles according to the provided range that satisfy the equation we've just solved. Number 11 now. Number 11 is on three-dimensional geometry. So we look at it. Three-dimensional geometry. Again, a very good question. A very good question. So let's look at it closely. Let's just look at it closely. The roof of our house, the roof of our house is in the shape of the triangular prism shown below. Triangular prism shown below. The roof of our house is shown below. So you can look at this triangular prism, calculate the angle between the faces, RSTU. RSTU, we can see the slope, the sloping face on the right-hand side, and PQRS. PQRS is the base. Yeah, PQRS is the base. So for you to find angles between two faces that meet at some point, you first identify the vertex through which they meet. So they are meeting at TU. Okay, they are meeting at SR. SR is where they meet. Yeah, SR is where they meet. So we draw a line through the first plane to SR, and also another line through the first plane that way, also to the same point. So the angle of our interest is this one. That's our angle of interest. Now, if that is the angle, then we can first identify. Let me even complete the triangle here. Yeah, I just complete the triangle like that. I complete the triangle like that. So with that angle identified, we need to know that this is 12, then this is 10, and then this is 8. So with that understanding now, to get this angle becomes very easy. We can let the angle to be alpha. Then we say the opposite length to that angle, which is 8 squared, equals to 10 squared plus 12 squared minus 2 multiplied by 10 and 12, the cosine of the unknown angle, alpha. This is according to what we call the cosine rule. Yeah, this is according to the cosine rule. So let me solve 8 squared. I subtract 10 squared. Then I also subtract 12 squared. This becomes negative 180. This is equal to negative 2 by 10 and 12. This gives us negative 240. The cosine of alpha. How shall you remain with the cosine of alpha? By dividing through by 240. I'm getting 0.75 positive. Yeah, 0.75. Then how will you now get the angle? By taking the cos inverse of 0.75. Now this value shall be shift cosine, giving us 41.41. Now, for you to navigate through three-dimensional geometry, be conversant with trigonometry and Pythagoras theorem. Trigonometry are both 1 and 2, because from both, you apply the simple trigonometric ratios, tan, sine, and cosine. But you can advance a question like this one, whereby now we just need now to apply trigonometry to the cosine rule, just as I have done. Very simple. You find yourself at the answers. Look at number 12, ladies and gentlemen. Just look at number 12. The equation of a circle is given by 2x squared plus 2y minus 12x plus 8y minus 6 equals to 0. Determine the center and the radius of the circle. Determine the center and the radius of the circle. So to determine the center, ladies and gentlemen, just to determine the center, we are supposed to first of all group the x functions together, the y functions together, the constants together. So 2x squared minus 12x. Those are the functions of x. Then we add 2y squared plus 8y equals to 6 becomes positive to the right-hand side. It becomes positive. So for you to solve this one now, you're supposed to apply what you call the completing square method. First, you ensure that the part which is squared has a coefficient of 1. So you divide through by 2 to leave this one now as x squared minus 6x plus y squared plus 4y equals to positive 3. At this point now we can say the x squared part minus 6x should become a perfect square on its own, whereby we add a constant. And how is this constant obtained? The constant is obtained by making sure that b out of 2 squared gives us that constant. That way, it will be a perfect square. Therefore, b over 2 squared, now it's negative 6 over 2 squared. You know, negative 6 over 2 is 3. When you square, you get 9. Then y squared plus 4y plus a constant to give us 3 plus 9, and also the same constant we add here. 4 over 2, then we square. It remains 4. So we also add 4 here. That way. We add the constants that we use to complete the square to both sides. Then now, we're supposed also to say that the x part and also the y function, they are supposed to be factorized. They are already perfect squares. So how do you factorize a perfect square? You take the square root of the first part, x. The sign that follows, a minus, the square root of the constant, 3. This one squared, plus, we also factorize, that is a y. The sign that follows is a plus. This square root is 2. Squared equals 2. This other side is having 16. Yeah, 16 that way. So at this point, we are now supposed to do one thing. We relate this equation to the general equation of a circle so that we be in a position to obtain the center coordinates and also the value of the radius. Then we move by saying this. X minus a squared, y minus b squared should give us the radius squared. This is the general equation of a circle. If that is so, then there is something that we're supposed to conclude again very quickly. That according to the specific equation that we have, then we should be able to say that x minus a equals to x minus 3. In other words, negative a equals to negative 3, meaning that the value of a is 3. Negative b equals to 2, meaning that b is negative 2. And therefore, the center for this particular circle is coordinate 3, negative 2. Then radius squared equals to 16, meaning that radius equals to the square root of 16, which is 4 units. Yeah, exactly 4 units. Exactly 4 units. I hope due to the spacing, we are not leaving out any question. I just hope that we are moving with every question. Let's check the next question now. Let's check the next question. So the next question says, we expand 1 minus x over 2 power 6 in ascending powers of x up to the fourth term. Very key, fourth term. Hence, use your expansion to evaluate 0.95 power 6 to 3 significant figures. So let's see the possible working of number 13. The possible working of number 13. So this is it. To expand, you start by stating the Pascal coefficients of the power, which is in question. So we start with 1, 6, 15, 20. Remember, we just need the first 4 terms, so you don't have to list all the 7 coefficients. Let's work with the ones that you've been given. Then now we start by saying 1 is power 5, then -1, negative x out of 2. Negative x over 2 is to power 0. In the next term, 1 takes power 5 and negative x over 2 takes power 1. 1 takes power 2 as negative x over 2 takes power 3. Remember, it takes power what? This is power 6, so we should ensure that the powers of 1 are descending as the powers of negative x over 2 are ascending. 0 to 1. So here we talk about 4. So that this one takes 2. Then finally, we'll have 1 taking power 3 and negative x over 2 taking power 3. Let's now carry out the real expansion. Anything power 0 is 1. 1 power anything remains the way it is. So 1 times 1 times 1. So in the first term, we shall have 1. From the whole of this, we shall get 1. Then we've said anything power 1 remains the way it is. 6 times 1 power 5 is just 1. And negative x over 2 power 1 remains the way it is. So 6 times half x becomes negative 3, the value of x. Then the next should start with a positive. Reason being, 15 times 1, because 1 power 4 is just 1. Then times negative x over 2 becomes x squared, and this becomes 4. So 15 over 4. Yeah, 15 over 4. 15 over 4 can simplify to 3.75. 3.75 x is now squared. Then minus 20 times 1. Negative x over 2 power 3 becomes negative x power 3. Negative x power 3. Then 2 power 3 becomes 8. So 20 over 8. This is 2.5 now. And the value of x is 2 power 3 that way. These are the 4 first terms of the expansion. At this point now, we can look at the application of this to estimate the value of 0.95 power 6. So we say 1 minus x over 2 is the same as 0.95. We can have this 1 over 2 becoming positive on the right-hand side. Then 1 minus 0.95 subtracted here to give us 0.05. How would you remain with x? You multiply both sides by 2, giving us 0.1. So the value of x is 0.1, meaning that we can substitute this value in the expression. 1 minus 3 into 0.1 plus 3.75. 0.1 is now squared. Then minus 2.5, 0.1 power 3. This is going to be 1 minus 3 into 0.1 plus 3.75. 0.1 is now squared minus 2.5, 0.1 power 3. This is giving us 0.735. I want to hope that I have expanded with some accuracy, more so the feeding of the values into the calculator. These are things you should be doing from that side to also ensure that accuracy is maintained. Don't just copy things. Please ensure that you are writing the exact thing. And actually, you can still use your calculator, 0.95 power 6, which is giving us 0.73509. So to three significant figures, the value is very okay. Number 14. The gradient function of a curve is given as dy dx equals to 3x squared plus 4x plus 4. Find the equation of the curve, given that the curve passes through the point 1, 2. So we are already given a gradient function, meaning that this curve equation has already been differentiated, because you have to differentiate a function to get the gradient function. How do we get back to the function? By integrating what has already been differentiated. So the reverse process of differentiation is integration. So to get back to y, we're supposed to integrate the gradient function, yeah, with respect to x. So y shall be the integral of 3x squared plus 4x plus 4 with respect to x. Then we say this function now becomes the general one. The power of x is supposed to increase. So if x is power 2 in the first term here, if it's power 2, it now becomes power 3, and the new power divides everything. So 3x power 3, and we divide by 3. The 3 cancels, and we get x power 3 plus the power again in the next term is supposed to increase. So it's power 1. It becomes power 2, and the new power divides everything. 4x squared over 2. It becomes 2x power 2. Then plus 4 has no x, meaning that x is to power 0 at that point. So now to integrate x power 0, power 1 is introduced. Then now, yeah, that is it. And we can also talk about now the constant of, the arbitrary constant of integration that disappears during differentiation. We reintroduce it. So this is the general equation for the particular curve. But what can we do to solve the specific curve equation? This is done by ensuring that we are given already here a point where the curve passes. So when the value of x is 1, the value of y is 2, according to this. So we substitute and say 2 equals to 1 power 3 plus 2 into 1 squared plus 4 multiplied by 1 plus c. So how do you get the value of c? We take 2, we subtract 1 power 3, we subtract 2 times 1, and we also subtract 4 times 1, giving us negative 5. Now, if the value of c is negative 5, then the specific equation to this particular curve can now be written. So y equals to x power 3 plus 2x squared plus 4x minus 5. So this is now the specific equation of the curve. Number 15. The first, the second, and the fifth terms of an arithmetic sequence are the first three consecutive terms of a geometric sequence. Find the common ratio of the geometric sequence. This one, again, is a simple question. You're supposed to know how a certain position of a number is obtained when given either arithmetic sequences or geometric sequences. And looking at the question, we just need the first term, which is A, the second term, which is now A plus D, and the fifth term, which is A plus D multiplied by 4. Yeah, for us to get the fifth term, D should be multiplied by 4. So this is the order of the terms from the arithmetic sequence. Then they are forming a certain geometric sequence, meaning that when the terms are divided, they give us a certain common ratio. So when we take the value of A plus D and we divide by A, we should get the same as A plus 4D out of A plus D. A plus D that way. Cross multiplication will give us A into A plus 4D. This is equal to A plus D, this time round squared. A squared plus 4AD. This is the same as A squared plus 2AD. I'm just using the quadratic identities to expand. So I don't use the long method of expansions. D power 2. That is it. So we need to get the common ratio. And of course, in its simplest form. In its simplest form. We can now start the grouping of terms. A minus A, that one cancels out. Then we can talk about the value of D squared. We can remain with that there, equal to 2AD. And from this, you can see that D can cancel out to give us D equals to 2A. So how can you remain with, okay, D has been expressed. Now that D has been expressed, then we can rewrite the terms and the value of D can be written in terms of A. So the first term is A. The second term is A plus D. So A plus, instead of D, 2A. And the third term is A plus 4 multiplied by, instead of D, 2A. So now we have A, we have 3A, and this is giving us 9, the value of A, meaning that now we can get common ratio. 3A out of A, which is just the same as 9A over 3A, which narrows down to 3. So the common ratio here is 3. The common ratio is exactly 3. A very good question, thought-provoking, requiring somebody to be very keen in what they are doing. Number 16 now. In a transformation, an object with area 12 square centimeters is mapped onto an image whose area is 24 square centimeters. Given that the matrix of transformation is x, 4, 1, x minus 1, find the value of x, hence state 2 possible matrices. And hence we state 2 possible matrices. Remember, we are finishing the section 1 in number 17. As we wind up, it's good I remind you of our mode of purchasing airtime. Simply to the M-Pesa, Lipa na M-Pesa option, the pay bill number 737356. The account number is the phone number that you're purchasing the airtime for. Then after that, now you can enter the amount you'd like to spend, complete the transaction, and you receive the airtime instantly. Remember, you can do the same for friends, whereby the pay bill number remains 737356 and the account number is the friend's phone number. This can be done for Airtel, Telcom, Safaricom, as long as the network is working in Kenya. Number 16, we should know that determinant of the matrix which is responsible for a certain transformation is usually equal to the area scale factor. For this case, I will even say that it is the absolute value of the determinant, because some other times you deal with a matrix and you get a negative determinant. Now you use the absolute value of that particular determinant. So we can say from what we are given here, we can get area scale factor, which is 24 over 12, giving us 2. The area scale factor is 2. This can be equated to the determinant of this matrix. How do we get determinant of a matrix? 2 by 2 matrix. Product of the elements in the leading diagonal minus product of the elements in the other diagonal. So x multiplied by x minus 1, then minus 4 multiplied by 1 should give us the area scale factor, which is our determinant of 2. This is x squared minus x minus 4 equals to 2. We can rearrange to have this as negative 6 equals to 0. Then now we solve it to get 2 possible values of x. Product negative 6, sum negative 1. These factors are negative 3 and 2. So now we can substitute them back. Instead of negative x, we say that x squared minus 3x plus 2x minus 6 equals to 0. Then x into x minus 3 and plus 2 here to remain with x minus 3 equals to 0. At this point, we can now pick from inside the brackets x minus 3, then from outside the brackets x plus 2 equals to 0. From the first bracket, the value of x shall be 3, and from the second bracket, the value of x shall be negative 2. Yeah, negative 2. So we have 2 possible values of x, meaning that now we can write 2 possible matrices. The matrix of transformation can be, when we use x as 3, it can be 3, 4, 1, then 3 minus 1, which is 2. That is the first matrix. Or another matrix can be when we use negative 2, this is negative 2, 4, 1, negative 2 minus 1 becomes negative 3. These are the 2 possible matrices of transformation that transformed a certain object with area of 12 to an image with 24. Thank you so much for turning up. Remember to subscribe and to share this lesson with your friends. Thank you.